Alright, today we're talking about perimeter and area of similar figures. So if we remember, similar figures means sides are proportional, angles are congruent. Alright, we've talked about similar before. Now, the ratio of the sides is A to B. Okay, whatever the corresponding sides, you compare them, the ratio is A to B. The ratio of their areas is A squared to B squared. Okay, if you think of that, area is two-dimensional, and that's why we have squares. Alright? First one here, we're told that triangle ABC is similar to triangle DEF. Right? So the first thing we want to do is put them in corresponding position. So if we use this as our original position triangle, that means I gotta have one that looks like that in corresponding position. And point D corresponds with A, so lower left. E corresponds with B, and then F corresponds with C, obviously. Alright, and looking at our triangle here, AC is 6. Alright, so now we know which sides correspond with which sides. Segment AC corresponds with segment DF. So they want the ratio now of the shaded to the unshaded of the perimeters. Okay? And if you remember back to when we talked about similarity, the ratio of their side length is A to B. The ratio of the sides is A to B. Ratio of the perimeters is the same as the ratio of the sides, A to B. And then the ratio of the areas is A squared to B squared. And we did talk about that back when we talked about similarity. So that is not new for us. Okay? So the ratio of the perimeters is the same as the ratio of the sides. And we want shaded to unshaded. Alright, so we take a look here. The ratio of the perimeters, this is part A, alright, equals shaded, which would be 9, to the unshaded, which would be 6. And we can simplify that to 3 to 2. So the ratio of the shaded to unshaded is 3 to 2. Now, what's the ratio of the areas, shaded to unshaded? So part B, well, the ratio of the areas is A squared to B squared, alright, and A and B are 3 and 2 respectively, so that is 3 squared to 2 squared, which is 9 to 4. Alright, so the ratio of the perimeters, 3 to 2, ratio of the areas, 9 to 4. Okay? Next one, you buy 2 rectangular pieces of aluminum, window screen, one is 15 feet long, it costs $135, the other is similar in shape and is 20 feet long. The screen is sold by the square foot, what is the cost of the longer roll? Okay, so we have, what do we know here? We want to set up a ratio. What do we know? We know that the 15-foot roll costs $135. Okay, so we want length divided by cost. So we want to set up our second ratio the same way. Length, well, we know 20 feet, and we don't know the cost. Okay, so now solve. Solve your proportion. Cross multiply, so we get 15 feet x equals 20 times 135, which is 2,700. Okay, and then that's dollars and feet. You know, multiplying the units as well. All right, divide by 15 feet. Divide by 15 feet. All right, feet divided by feet, those cancel. We're left with dollars, which is good. It's a good sign because we are looking for the cost. So 2,700 divided by 15, we get $180. So the 20-foot long roll is $180. Alright? Next one. A large rectangular billboard is 12 feet high and 27 feet long. A smaller billboard is similar to the large one. The area of the smaller one is 144 square feet. Okay, so you have a big billboard where you know you have 12 feet and 27 feet. We have a smaller one, and we know the area is 144 feet squared. Okay? Now find the height of the smaller board. We want to find the height. Okay? So, what do we know? Well, we don't have anything that is corresponding that we know for both figures, right? The values. We have the height, don't know the height. We have the length, don't know the length. We know the area, don't know the area. Well, think a little bit more. Okay, this one, all right, we have the height and the length. Can we find the area here? And the answer would be yes. Okay, you take 12 times 27, so the area of this one is 12 times 27, which is 324 feet squared. Alright, so now we have something to compare. We can compare areas. So we have the ratio of the areas is equal to 144 feet squared divided by 324 feet squared. Okay, feet squared divided by feet squared, those cancel out. The ratio of the areas is 144 to 324. Now if you think about this, okay, go back here. The ratio of the sides is A to B. The ratio of the areas is A squared to B squared. Right now, for this problem that we're working on, we have the ratio of the areas. How do we go from here back to there, the ratio of the sides? We have to get rid of this squared, right? So we got to take the square root. Okay? So we got to take the square root of that. So the ratio of the sides is going to equal the square root of 144 to 324. And if we do that, the square root of 144 is 12. The square root of 324 is 18. Alright, and then we reduce that to 2 to 3. Okay? So we know the ratio of the sides is 2 to 3, which is equal to, and that's small billboard to large billboard, to the heights. We don't know the height of the small one, and we know the height of the large one, 12 feet. Alright, so now you have your proportion solved. So you get 3x equals 24 feet, divided by 3, x equals 8 feet. So the height of the smaller billboard then is 8 feet. Okay? Alright. Last example here. This one's a little more complex. Stop sign rug is a regular octagon. Each side is 2 feet, and the area is about 19.3 square feet. You make a stop sign mat with a perimeter of 72 inches. Find the area of the mat to the nearest tenth of a square inch. A couple different things going on here. Alright, we have our stop sign rug, which has 2-foot sides. Okay? And it has an area of 19.3 feet squared. And then we have a mat. I'm not drawing the whole thing, but we know the perimeter is 72 inches. Okay, now, we know they're regular. So when it's regular, that means it is equilateral and equiangular. It's an octagon. Okay, so 72 divided by 8, that means these side lengths are 9 inches. Alright? This one is inches, that one is feet. Well, that's 9, we can't convert that to feet real easy, so 2 feet, we can convert that real easy. That's 24 inches. Okay? So, we know the ratio of the sides is 9 inches to 24 inches. Inches divided by inches, those cancel out. 9 and 24 have a common factor of 3, so we get 3 to 8. The ratio of the sides is 3 to 8. Okay? Now, if we want to talk about the ratio of the areas, because we want to talk about area, we know the area here, we don't know it here. Alright, the ratio of the areas, that is A squared to B squared, right? Well, A and B, that's 3 and 8 respectively. We get 9 to 64. So the ratio of the areas is 9 to 64. Great. So the ratio of the areas, 9 to 64, which equals, we don't know the area of the small one, x. We know the area of the larger one, 19.3 feet squared. Okay, you have a proportion. Now solve. Okay, we cross multiply, we get 64x equals 9 times 19.3, which is 173.7 feet squared, divided by 64. X equals 173, that's 2.71 feet squared. Alright, 173.7 divided by 64. Now, so that's the area of the smaller one in feet squared. They want it in nearest tenth of a square inch. Nearest tenth of a square inch. So we want to change it to square inches. Okay, we're going to do a little bit more work yet, because that's square feet. We need square inches. So, we got 2.71 feet squared. Right, that is a fraction that's over 1. Times. Think about this. 1 foot squared. 1 foot squared is the same as how many inches squared? And if you think about that, 1 foot squared is 1 foot by 1 foot. Right? 1 foot, 1 foot. The area of that is 1 foot squared. Okay? 1 times 1 is 1. Feet times feet is feet squared. Well, 1 foot, that's the same as 12 inches. That's the same as 12 inches. So the area is also, well, 12 times 12 is 144 inches. Inches, that's inches squared. Okay. So, 1 foot squared is the same as 144 inches squared. And now we have feet squared divided by feet squared. Those units cancel. The units we're left with, inches squared, which is what we want. And then 2.71 times 144. Alright, we get 390.83 inches squared. Now, they wanted it to the nearest tenth. Okay, so that's really 390.8 inches squared for that smaller mat. Okay, so this one is a lot more complex. You had to worry about converting units. You had to worry about using the ratio of the sides to find the ratio of the areas. Once you had the ratio of the areas, find the area of the mat. Okay, we have the area of the mat. Now we needed to convert it to the proper units. So, a little bit of work involved with this one. Make sure if you have questions, you're asking them in class. Thank you.